Today, I'd like to share some tips to make your architect flows better and more efficient. First off, let's talk about some different things that can cause warnings and errors either while building an architect flow or at runtime, which is even worse because then your customers could experience them. First off, you see by default, certain elements in architect flows will generate warnings when no audio sequence has been set. And there's been a fair amount of debate about the best practice for this, but the current best practice is to use the expression to audio TTS, so using the to audio TTS function, and then pass in as the only parameter the literal not set value. The reason for this, rather than inserting blank audio or something else, is that using this expression will not trigger the audio subsystem at runtime, so it will make your flow a little bit more efficient, and it will get rid of the warning. So you'll notice I did that for the initial greeting, and a transfer to ACD step, and the transfer to flow steps with the pre-transfer and failed transfer audio would also require doing something like this to resolve those warnings in your flow. One of the things I believe is that you should have an error and warning-free flow just to make sure that when you publish it, it is clean and any developers following you don't wonder why things were built that way to leave warnings. And of course, if there are errors in your flow, you will be unable to publish. Now, another issue you can commonly run into is an architect flow that will fail at runtime due to variables that are either empty and have a value you haven't expected or an actual not set value, meaning that the variable has never been used and has never been set to a value in your architect flow. And there are a number of actions that if you take those actions on a variable that has not been set, it will cause your flow to actually fail. But also how you handle variables can make your flows more efficient. And flow size can be important for more significant flows. We'll come back and talk about flow size in a minute. First, let's talk about some different ways to handle not set values. One of the common use cases for this would be getting participant data. If I retrieve some attribute and I write its value to a variable, in this case it's a task scoped variable, if I then try to do something like this, where I add a decision and I just check, if I did a logical expression like task.value equals some value. This, if I retrieve this attribute and it does not exist on the conversation, and I perform this logical expression or logical decision based on that variable, my architect flow is going to hit error handling because the value has never been set. And there are several ways to handle that. One way is to wrap your logic in an if function, and the if expects three parameters: a condition, a true, and a false. So I'm saying if task.value is not set or empty, then use the literal value false, because remember a decision expects a Boolean value. And if it has a value and is not empty, then check this expression, task.value equals example. And if the value is example, it'll take the true path, or the yes path. If false, it'll take the no path. Another way is to use a function that handles a not set value. And the r=equal function does that very nicely. The first parameter is a Boolean indicating whether a case insensitive comparison should be performed. And then the next two values are the input value and the value to compare it with. Those could be in either order. It's just checking, are these two parameters equal? Is the value of this variable example, and because I passed in the true flag, it will compare it whether it's uppercase or lowercase. And the nice thing about the r=equal function is that it will allow you to have a not set value, and it'll just take the false path. I can also perform this kind of an expression if I am trying to retrieve value. So let's say that I want to that this is a data action input, and I want to pass in the value of this variable and have this variable called task.value. Maybe it's a bad name. It's just an example. I can wrap that just like I would in a decision. I can wrap that in an if is not set or empty function, and I can say if my variable is not set or empty, then pass this default string, because in this case I'm doing a string, but it could be any data type, and otherwise use the actual value of the variable. So that's a way you can help make things like data action inputs null safe as well. All right, let's go back and talk about making flows a little more efficient from an action standpoint, because not only can a flow get too big in a flow size, and you can see that over here. If I look at my breakdown of my flow, I can see the overall percentage, and if that gets too high, you'll be unable to publish or save your flow. And one of the ways is to minimize the number of actions you take. So I could chain different update data actions together, set variables in each of them to different values. Or a more efficient way to do that is to do them all in one action. It makes the definition of my flow smaller and will run more efficiently. Another way to make flows more efficient at runtime is how you build strings. One way is by concatenating different strings together using the plus character, and you can do this. String plus string plus string, including variables, will equal a resulting string. But the problem is that each of those elements will then use a memory space at runtime, and it's far more efficient to use the append function. You can use it to build exactly the same string with string values, passed in variable values, etc. And the other advantage to using the append function is that this method, if I pass in a literal reference to a variable and want to put that as a literal value in my string, and this is a not set value, that will result in a flow error. But the append function accepts parameters that are not set. So I could pass in a literal not set, or this variable could be not set, and that would not affect building my string. You do have to think about, though, if you're building TTS strings, you would need to think about what might happen to your string and the playback of that if you did pass in a not set value. All right, let's talk about a few other things. We mentioned prompts as far as building TTS strings. There are different ways to do that. I can play a prompt, and that will play the appropriate value. So in this case, I'm using text-to-speech, or I have an audio resource for the language in question. And I can play that directly from the prompt object, which I would want to do if I were playing a static message. But in many cases, you may be building dynamic strings for self-service playback. So you might have a complex string that plays back user's account balance and due date and things like that. And there are several different ways to do that. Just as an aside, I can also increase the efficiency of my flow instead of having a prompt statically referenced, because this then shows up as a dependency in my flow and will increase the size of my flow. But if I had prompts that I wanted to dynamically play, I could retrieve those from a data table or have a dynamically built value for the name of the prompt. So maybe it would be something like append prompt name and some other variable or value to build that prompt name. And if I wrap that in the find user prompt function and then to audio, then that will dynamically look up the prompt by its name and play it without it being a direct dependency in the flow. And that has pros and cons. A prompt that is a dependency in the flow and is statically referenced will be included as a snapshot in an inbound call flow when the flow is published, so that if the prompt is changed later on outside the flow, that flow will not break and or have its audio content changed until the flow is edited and republished again. Keep in mind, though, that is only true with an inbound call flow. It is not true for bot flows. So these are a different type of flow. And any prompt resources, which I don't have any here in my example one, but any prompt resources that are referenced in a bot flow are referenced at runtime and will always play the latest version of a prompt. So playing prompts dynamically is one way to make your flow more efficient in size. Keep in mind there are limits on the number of dynamic prompt lookups and other object dynamic lookups within an architect flow. Now, as if I'm playing a sequence of actions, maybe a partial prompt, some value from a variable, another prompt, and this could be a whole sequence of things, I could do it as prompt, variable, prompt, variable, prompt, variable. But that makes my flow definition a lot larger because the flow has to remember these sequence of items. If I'm doing something that involves a text-to-speech string, it's much more efficient to use my toAudio TTS function and then dynamically build using the append function the sentence that I want to play. So it could be something like, your current account balance is such and such, and your due date is such and such, and whatever other information you wanted to build into that sentence. And that will be far more efficient from a memory perspective and size perspective for your flow than building them as a sequence of prompt objects like this. There may be cases where you want to use one over the other for clarity. And these are just some suggestions to make your flows more efficient. Now, speaking of errors, when a flow reaches an error condition, the default is to play a message, sorry, an error occurred, please try your call again, and disconnect. That's not terribly customer friendly for the CX of the flow. A better method would be to jump to a reusable task and define some logic that you want to happen when an error occurs in an architect flow. And I might want to not play a prompt here. I might want to, based on what happens, do something different. So I could use my whole toAudio TTS not set, and then jump into a reusable task where I could maybe log some information about the flow where the error was generated, play some type of a friendly message, transfer the call to a queue, whatever the behavior I want to happen if an actual error occurs in my flow, which means in general that I made a mistake in my flow. Now, if there's something wrong with Genesys Cloud, you could reach an error condition as well. But for that to happen, generally there's something else pretty awful going on in the cloud. The point being, it's good to have a friendly error handling for your customer experience. And architect flows as they run have a 10,000 step limit. But if I use this mechanism of jumping to a reusable task, then I get an additional 1,000 steps in my reusable task to be able to gracefully handle that error rather than just taking the default behavior. Now let's talk about some high-level efficiency steps. If I am building a flow that makes use, for example, of a data action, I could reference that data action in several different places in my flow. So if I had something where I think I'll use an example here of getting some policy information, or maybe I pass in a phone number and I get back some information about a caller's policy. If I needed to use this at several different places in my flow, I could use this call data action as many times as I want in my flow. The downside is that the more complex my data action is, the more space that's going to take up each time I use it. It's much better to build a single reusable task, put my data action and any surrounding logic in that task, and then call it from somewhere else. using the call task action. So I can now reuse this little piece of code, including any error handling and success handling that I want, from anywhere inside my flow. And if I need to change that data action and how it is handled, I only have to do it once. So that's a good policy in general. Whenever you have logic that you find yourself reusing, drop it inside a reusable task and make that reusable throughout your flow. You could also take that one step further. If you have a significant reusable component, you could drop that into a common module and call that common module from within your flow. Just keep in mind that that does increase the size of your flow. So you want to use common modules. I wouldn't necessarily say sparingly, but with care. Make sure you have something that is worth building into a common module and reusing. If you have a large amount of data that you need to retrieve or a collection of data, you could hard code that. So I could define a variable and I could define its default value here in a flow. I could define all kinds of data inside my architect flow. Just keep in mind that any of that data that you hard code in your flow influences the size of your flow. It's much better from a flow configuration perspective to retrieve large values or sets of data from data tables, data actions, or other external sources so that they are only used in memory and don't significantly affect the size of your flow as far as its static configuration goes. We talked about how inbound flows versus bot flows handle prompt objects. I'll remind again that you can dynamically reference a prompt using the find user prompt function. There could also be cases where you may want to use the built-in find actions to look up an object. Just keep in mind that anytime you add another action to your flow, that increases the size of your flow that needs to be saved and then published. But for a data action, another thing to keep in mind, sometimes a simple data action like this with a few inputs and outputs, it's not a big deal. But if I had a data action that had an awful lot of inputs and outputs, maybe it's a complex healthcare policy or something like that, and it returns a very large JSON object with nested arrays and different pieces of information, it's often better to simply return that value from the data action as a JSON string, parse that string to a JSON data type, and then extract the value, the specific values from the JSON object field. So in this case, I'm getting a JSON object property from my root response object. There's a field called success, and I'm converting it to a Boolean that I could then check. Now, I could reference that object directly. So in this case, I'm wrapping, just like we talked about earlier, I'm wrapping an if is not set or empty to that success field, default being false, and then checking its actual value if it is set and has a valid value. But I could also extract that to a variable if I was going to use that in my flow. In fact, a success may not be the best case, but if I had a field that I wanted to use throughout my flow, I could scope that to the flow, and then instead of having to have a complex expression, I could just reference flow dot whatever that variable was to then handle throughout my flow. Let's hop over to bot flows for a minute. Another way to make your flows more efficient is any flow like a common module, a bot flow, and even reusable tasks that you might want to pass data in and out of. Keep in mind that any data that you have as an input or an output, any variables, those also increase the size of your flow configuration. So if in a bot flow, if I create a new slot, I'm just going to create an example slot based on some existing slot type. By default, a new slot is set as both an input and an output. and that can increase the size of your bot flow configuration. And every time you call that bot flow, make your calling flow, it can bloat your calling flow. So unless you need it to be an input or an output, uncheck those when you create a new slot. Now within a bot flow, there are a number of things I can do to increase its efficiency and decrease its size. Going back to the slot example, if I were to create a slot, let's say for an example menu, and I use a new list type, and I might have, let's say sales, and I have DTMF digits and synonyms, and maybe support, and some other DTMF digits and synonyms, maybe an agent option, and whatever else that might have. I can do that, but the difficulty is if I create a whole bunch of these in my bot flow, every single one of those takes up configuration space, and every time I call it, also takes up additional configuration. It's far better to do something dynamic. So if I, for example, create a dynamic slot linked to a dynamic list, I can then set the values, the collections for that to variables. So I earlier defined a list, a collection of strings for values, a collection of strings for synonyms, and assigned those flow scoped variables to my dynamic slot type that I had created. Then I can pass in a list of input values, and I'll show you a couple ways that I could do that. So I could, anywhere in my flow, define a collection of strings, and let's set my flow.dynamic slot values. So these are going to be the slot values. Maybe have sales, support, agent, and then I could do another collection of strings for my dynamic slot synonyms, and that could be 1, comma, place an order, 2, comma, and so this is my comma delimited list of synonyms for each of the matching values. The third would be 0, representative, etc., whatever I want those to be. I could do that each time I want to make use of my dynamic slot. The problem is that every time I have an update data action like this that sets a dynamic collection with static values, that's going to increase the size of my flow configuration. It is far more efficient than creating different slots and setting my update data all the time to have something like this where I'm setting my flow scoped values and synonyms with a passed in value that gets reused. So in this case, I call my dynamic slot task, and I have defined task scoped list or collection of string variables, and I can pass in those same inputs for both my values and synonyms every time I want to call this dynamic slot task. Now, do keep in mind that each time I would want to use this, I would want to start out by clearing my dynamic slot so that it doesn't just take whatever the last response was from the caller. But that gives me a completely reusable dynamic slot with dynamic values that I can pass in instead of referring to individual slots with individual values, and can make your flow a lot more efficient. Now, increasing a hard-coded list slot doesn't necessarily make your flow a lot bigger, but referring to different slots throughout your flow definitely does. So I hope that some of these tips will help you as you are building architect flows to make your flows not just more efficient, but more effective at runtime with fewer errors and a better caller experience.